My name is Andrew Whitehead, and I am in the chemistry online course. And today my project is going to be over the periodic table. And with the periodic table, I've learned that it's been important to chemists since the late 1800s. It's been used by chemists, it's been used by chemistry students. The periodic table has been a very crucial part of science. So without the periodic table, it'd be a lot harder to kind of understand what goes into the chemicals and metals and everyday stuff that we use. Without the periodic table, we probably wouldn't even know what elements that we've found or still have defined in the world. The periodic table was created by Dmitry Mendeleev. The periodic table is made up of 118 elements. It's going to be made up of metals, nonmetals, gases, noble gases, as well as transition metals. 6 of the elements are metalloids, 18 are nonmetals, and a whopping 94 are metals. Metalloids have a solid state of matter in general and have a metallic appearance. They're very low elasticity, so they can only stretch so far. They're brittle, and they're also semiconductor elements. So if it's a semiconductor, it's a possibility that it could hold charge. If it's a conductor metal, it's definitely going to hold a charge of electricity. Nonmetals can be solid, they could be liquid, they could be a gas. It all just depends on the temperatures. Some of them have boiling points, some are negative boiling points, in which case, it takes a lot more to actually be able to melt them down. They're typically not shiny, and they are poor conductors of heat and electricity, nonmetals are. And metals are good at electrical heat conductors, they're malleable, they're ductile, and solid at room temperature. They tend to have higher boiling points than a nonmetal or transition metal. The periodic table is arranged into 7 horizontal rows called periods and 18 vertical columns called groups. The vertical columns are called groups because of their similar chemical behaviors. The most unique group are the noble gases, which include the elements helium, neon, argon, krypton, xenon, and radon. Xenon to me is a very interesting chemical. If you're familiar with modern cars, a lot of headlights are going to xenon, and it's a brighter light. And how they turn that chemical into a light, to me, it's amazing. These gases are the most stable due to having the maximum number of valence electrons. Therefore, they rarely react with other elements. Elements like alkaline metals, like lithium, sodium, potassium, all of those, they're very reactive. They have electropositive monovalent metals, and they form strong alkaline hydroxides. Alkaline earth metals, on the other hand, are very similar, but they're going to be more like magnesium, calcium, barium, things like that. And they're reactive. They also have an electropositive, but they're divalent metals, and they form basic oxides, but they're more reactive to water, creating hydroxides. Like a little bit of weaker hydroxides. We have chemicals or elements like lanthanides. Lanthanides are kind of interesting to me. We also have actinides, and these are elements that have unfilled orbitals. Lanthanides are metals with reactivity similar to group 2 elements, which is going to be like magnesium, calcium, stuff like that. And then you have actinides, which are radioactive elements. So, lanthanides are going to be used in optical lenses like night vision. And so, they use petroleum refining and also alloys to be able to create night vision or basically radioactive things. And then you have actinides, which are valuable, and they're used as energy sources for things like pacemakers, electrical instruments on the moon. They're used for uranium and plutonium, and they tend to be used more for nuclear weapons and nuclear power plants. And so they can get pretty dangerous. So we have row 1, which is going to be your alkali metals. We have row 2, which is going to be your alkali earth metals. We've got row 3 through 12, which is going to be your transition metals. We have element 51 through 71. That's going to be your lanthanides. We have element 89 to 103. That's going to be your actinides, so your radioactive elements. Element 109 through 111, 113, and 115 through 118. They're all going to be unknown properties. Elements 5, 14, 32, 33, 51, 52, and 84 are going to be your metalloids. And they're going to be, I can't really give you a row because they go into several different rows. But anyway, all these elements in the periodic table are in horizontal rows or vertical rows. For example, hydrogen and helium have one orbital for its electrons, and the way that the horizontal works is they're based upon the atomic number. And so the atomic number is made up of the amount of reactivity to protons, and then you have your atomic, your mass number, which is going to be your protons and neutrons that come together to form the chemical or the element. Hydrogen, helium, they have one orbital for their electron. The second row containing boron, carbon, nitrogen, oxygen, and fluoride have two orbitals for their one electron. This continues all the way down to the periodic table until period 7. In the top left-hand corner of the elements square, you're going to have your atomic number. Like I said, it's indicative of the number of protons in the nucleus of the element. The number of protons identify the element despite the number of neutrons and electrons. Together, the number of protons and the number of neutrons determine an element's mass number. And so, like 54 xenon your atomic mass number of 131.29 is going to be based on the amount of protons and neutrons you have within that element. The number of protons identify the element despite the number of neutrons and electrons. Together, the number of protons and the number of neutrons determine the element's mass number. If you want to calculate how many neutrons an atom contains, you can subtract the number from the mass number. For example, oxygen's atomic number is 8 with a mass number of 15.003. So, in order to calculate the number of neutrons, 8 must be subtracted from 15, resulting in 7 neutrons. The symbols in the middle of the square is called the atomic symbol. So H is going to be helium, Na is going to be sodium, Mg is going to be magnesium, and so forth. These symbols represent the names of the elements. And so each symbol, the symbol doesn't always match to what the element is. Like Au could be gold. The symbols, they represent the name. And the symbols were also first created by John Dalton. The atomic symbols were created based on the Latin names of the elements, as well as a few English names. So, Au is going to originate from, comes from the Latin word for gold, aurum. Some facts that I found and interesting about the periodic table and the elements are carbon is unique in that it's known to form up to 10 million different compounds. Carbon is also important to the existence of life because without carbon we don't have oxygen. And francium is the rarest element on Earth. The only letter not in the periodic table is the letter J. And the last one is helium on Earth, and it was first discovered by observing the sun. So without each of these elements, we almost wouldn't have life. You see, without hydrogen or carbon, we don't really have anything to keep us alive. Same with oxygen. If we didn't have all the plants absorbing all the carbon dioxide, turning it into oxygen, we would not exist. We wouldn't be here. And it's kind of like how we're just slowly destroying the ecosystems. With all those trees going, we're basically just selling ourselves short because we're polluting the earth with massive carbon dioxide and not really leaving any trees left to help filter the carbon dioxide and turn it into oxygen. And so we're kind of inevitably dooming ourselves. But that is my presentation on the periodic table. Unfortunately, I didn't really go into a whole lot of the elements, but I do hope that you learned something from the elements, and also a little bit about the periodic table, how it was formed, some of the elements that go into creating it, and also how the periodic table is important to chemists. It's kind of like our labs, without the periodic table, it would be a lot more trial and error. We would be basically just mixing random chemicals in hopes that they don't just explode. Obviously, chemists have done that, they've mixed plenty of chemicals together to really understand what reacts with what, and what just creates a reverse effect, which creates, inevitably, it creates destruction. Because if you mix specific chemicals, they learned how to create mustard gas through just mixing these chemicals, and the periodic table has helped to stop from just creating accidents like that. But it's all done through trial and error. But thank you for listening to my rambling on about the periodic table, and I hope you enjoyed it.